So, about plants, first off, I like to go over like just some I guess things about their phylogeny, maybe like the different groups. So, what kingdom are we for sure in? So, for sure the kingdom is Plantae. Yes, ma'am. And then I think we remember that what is the most common, recent common ancestor of the like modern land plants? Cariophyceans are the most recent common ancestor. Probably their major organelle would be obviously the what? Chloroplasts. Which are derived from what? What are the chloroplasts derived from? Yes, it's the endosymbiotic theory of the cyanobacteria. Cool. And we talked about photosynthesis in one class the other day. I forget which one it was. Was it? Awesome. But one thing that we do need to kind of go over is we need to kind of talk about, I think, some of the different groups of plants. So when I think of plants, I think of like four major categories. I think of our mosses. I think then of what's your fern plants? Then your cone-bearing plants, your conifers, and then your flowering plants. The conifers are collectively called the gymnosperms, the cone-bearing plants, and the flowering plants are collectively called the angiosperms. And so right here you have the four major groupings of plant groups. And you could say bryophytes right here. I probably butchered the spelling there, but pteridophytes, the fern plants. And bear in mind that there's like multiple like groups. Bryophytes is a good example of a moth. Pteridophytes is a good example of fern, but there's actually more. And this is like an old school breakup of four phylum. I think now there's actually more realistically like 7 or 8. But I still like this, and I think this is applicable for APs. I think another thing we have to like be concerned about is like these divisions that exist. So when you look at a division right here, I think you are completely vascular to the left. I'm sorry, to the right of this line. But before that, I would say that you are non-vascular. Everything to the left of this line, I think, would be considered seedless. As opposed to everything to the right would be having seeds. Correct. And of course the difference between these two is the cones versus the flowers. So I think we got that. Alternation generation. I think it's like one topic. I think, did we go through that in here today? So this will be a great review and a real quick review. Where do we want to start at? I know where I want to start at, but it's indifferent to me. Which would be like what? That's better today, I think. Kind of. What's the, I would say the sporophyte diploid, right? And what is it doing? To get to the spore? And so your spore has to be in, right? So it's got to be meiosis that's happening there. And then what does that little spore grow up into? Yeah, so I'm just going to write the word flower today instead of trying to like actually draw one, because it went really bad yesterday, as I recall. The flower is going to be the gametophyte. And that would have to be mitosis, absolutely. So the gametophyte, of course, would be haploid or just N. And then from there, your flower is going to be doing what? Producing little eggs and sperm. Would that be through meiosis or mitosis? Mitosis, because your gametophyte structure was already haploid, so the egg and sperm, which are haploid, you don't have to do like a division. And of course, these two come together, and then you have the little baby zygote. The zygote, of course, would be diploid, 2N. So is that going to be mitosis, meiosis, or actually a different one? Fertilization. And of course, then you would do successive rounds of mitosis, and that would get you actual sporophyte structure. Cool. Remember, the modification that we would view for the sake of us is that we bypass this gametophyte structure that exists on the body. Yay? Awesome. Let's see. Trying to think of anything else that I want to talk about that's amazing. I think we understand like the difference between like vascular tissue versus non-vascular, right? Vascular is going to be like silent phloem having. Looking at the angiosperm group, going back up just a little bit for a second, I think when you discuss the angiosperms, you actually could break these up into two very, very large groups. One's going to be the monocot group. There's going to be the dicots. Your monocots, what are they responsible for doing? Or give me some properties of them that are put. Okay, so definitely we can identify these as being like your grasses. So here's someone say wheat. Yeah. Anything that is like a grass-looking structure, corn would be in this category. A dicot's going to be more of a fruit or a tree. Tell me about the root system. Right. Perfect. I would say monocots typically have parallel veins. Whereas your dicots have non-parallel, and I don't mean perpendicular necessarily. Veins that go everywhere. Think about like the leaf, the orientation of all the little lines throughout the leaf. Let's see. What else? Which has one cotyledon? Who has one cotyledon? So what is a cotyledon? It's inside. It's next to the. It is within the seed. It's a baby leaf. So when the seed like opens up, monocots have one little baby leaf, as opposed to dicots, which have two cotyledons, which means there's two little baby leaves. I literally mean that the leaf that is prepackaged inside of the seed. Cool. Yay. For me, this actually covers what you're seeing right there. It's chapter 29/30. Cool. So then the next thing to go through would be at the start of chapter 35, which will be fun. And I'm trying to look at something really quick. I have like a picture I want to show y'all. Let me get y'all to copy down this picture real quick. something really, really simple. The left or the right one, decide which way. So I'm going to take these little structures apart. Either one. Or either one. Weedy, but not good. This picture that you're seeing right there is going to be from chapter 35. And this actually is what starts up our chapter 35 material. Chapter 35 is all about plant structure. If you remember from this time frame, this plant structure that was like the most difficult part of the plant chapters. Node is the actual attachment point. Internode is the space between the attachment points. So, looking at that picture, definitely I think one of the first things to notice or to write down would be about your node or what a node is doing. So, node definitely would represent the connection point or the attachment point. The internode is going to be the space. Between the nodes. And when we talked about plants, we mentioned a couple other things, like we mentioned apical meristems versus auxiliary meristems. Teaching days. What is an apical meristem? Right. So it's a area of upward growth. What's the auxiliary meristem? That's going to be for more of an outward or a thickness growth. Cool. Now continuing this, I think it was like, I always like to generate this rule of 3 that you see with plants. Do you remember my rule of 3? 3. Yeah, seriously, like that's... Three, perfect, and then 3 organs too, right? 3 organs, because if you remember from back in the day, like what's the most basic level of biological organization? Like what is the lowest? Go chemistry. Atom, and then of course then it's molecule, right? Molecule is what's next? Help me out, guys. What's after molecule? Organelle. After organelle, cell, and then you had non-visible getting important cell. Then it was what level next? Tissue, then tissue, organ, and then system, organism. So what I want us to focus on is I want us to focus on like the 3 types of cells, and then like continuing on from that to talk about the types of tissues and organs. And I think that'll work out moderately well. So let's go there real quick. What are the three organs that we're going to focus our efforts on? Definitely the roots. And I heard someone say stems. Okay. When we say stems, we also mean like just in general the term shoot, which is like any growth that is not leaf growth above the soil. So I'm going to find some pictures real quick. I wanted to show. As far as like your roots go, describe their properties. They can occur in two forms. Obviously, there's the taproot form versus the fibrous root form. That's one thing we need to know. What else is going on down there? Okay, so they absorb nutrients from soil. When you think about that, absorbing nutrients from soil, I need to write down another heading or like a little section at the bottom, and I need to go over a process. What process do I need to go over about absorbing nutrients from soil? I can talk about that in just a second. Now it also is the amount of root pressure that's created, because this is not just an absorber of nutrients from the soil, but it's also water too, right? So we talk about the root pressure that's created, which actually causes the push that we see in the leaves. What else does the root serve to do? Definitely like an anchorage, right? Anchor and support. Cool. What else? I think I heard someone say something different. Storage area. What does it store? What would there be needing to store in the root? Be more specific. Sugar. Remember, it's the sugar sink. Your stems and shoots, of course, are what are responsible for what? This is like the area of like transport, attachment. Right? That's really kind of about all for stems that I kind of need to go over. And then leaves, of course, are responsible for what? Right, they're the photosynthetic area of the plant, which means they're the sugar-making part. What else are they doing aside from photosynthesis, though? Stop exchange. Remember, when you look at their opening, which is called the what? Which is flanked by, so there's a guard cell right there, a GC as I like to call it. What's going in? CO2 goes in. What goes out? O2. And that's another feeling, and it goes out. What else goes out too? Yeah. What's that called? Transpiration. Does this represent the push or the pull that water experiences? The pull. So now you've got two things working against the water. The push that you see in the ground, and then the pull that you see with transpiration. Cool. Let's see. A good commonality between all these is that they all have the three tissues at each level. Now, we'll go over that in just a second, but just go ahead and throw this out. The different tissues are going to be what? Vascular, dermal, and what's the last one? Ground. And they're all three found at each level. That's kind of unique, because if I say cardiac tissue, would I find cardiac tissue in my big toe? No. So like typically tissues are very, very like area specific or organ specific. You see the three major tissues found in each of those three areas. Cool. The different types of cells. Yes. Now before I go like that, right? The three types of tissues and then the three cells that Lindsay's asked for. Let's talk real quickly about cation exchange, which is occurring where? In the root script. Okay. What's that right there? A leaf? Definitely a root. Why are you drawing this? Is this important? That's not a knife, that's a root. How do you know it's a knife? This could be zoomed in, Joseph. So, definitely what ends up in the roots. We already said it's distinct for what? So, we know that when you take sugars, and first off, let me ask this question. Are the roots growing? I mean, are they expanding in their area? Or do they just like, I don't know, like when you plant the little seed, just the roots just like poof out all of a sudden? That there has to be growth over their duration, right? And would expansion, would that be intragonic or extragonic? Yeah, would root growth be ender or extragonic? You're going on the right track. It needs power, right? It needs to be powered. So that means you'd have to take sugar and do what with it? Yeah, combust it. Who does this reaction? Obviously the root does, right? But everyone does because this is respiration right here. Right? Now these two little products, the H2O and the CO2, go out. They exit out the roots. Much like they would exit out of your body, they exit out of the root essentially. And you're left with H2O and CO2, and they kind of come together to form H2CO3, which is what? Carbonic acid. And like any acid, it has the possibility of breaking down, thank you, into, Carly? It has the possibility of breaking down into HCO3 minus plus H plus. What is the name of HCO3 minus? Bicarbonate. Where have we seen bicarbonate aside from like outside the roots? The pancreas, somewhere else. You see it in the kidneys too. You see it everywhere. But it's also, I want you all to know, it's like the buffer system that's in your blood. That's what your CO2 combined. Your oxygen, or when you do combustion, you do essentially the same thing. You do the same thing. That's how you carry CO2 back to your lungs, is bicarbonate. Over here I need to draw this little particle. What's this little particle that's in the ground right next to the root? Soil. And what's the charge of soil? Negative. So that means that little Mg2 pluses, that's magnesium with a 2 plus charge, or little K pluses, or little Ca2 pluses, would all be right next to or attached to that negatively charged soil, like a magnet. Now, when you do this reaction of releasing the H2CO3 from the product, basically of combustion or of respiration, and you form the H plus ion as a part of the dissociation of the carbonic acid, the H plus has an ability, I've lost my addition sign, has an ability to come in, and if you get the numbers high enough, kick out some of your vital ions. And you see what we have going here? We have a case in which your important cations that are vital to processes, like we've already described, how potassium regulates the GCs. What's the GC again? The GAR cells, and therefore can regulate the opening and closing of the stomata. So your K pluses, Mg2 pluses, Ca2 pluses are able to go in by this exchange of H plus. Cool? Awesome. So your soil becomes essentially acidic. Now, let's one up this, or actually, if you think about it, this is going to be a one downing this. And then some, right? Whatever. Let's say you live in a very industrial zone where, instead of being very pretty, it's... Oh, God. Oh, God. Let's say you live in an industrial zone, and your clouds are tainted. These are clouds. Purposely yellow. You just threw that into my sink, dude.
That's actually on the backpack. I got it.
The other day you threw it on my backpack. And today, that's like a couple days ago. At any rate, what's wrong with these clouds? It's not because I have a lack of colors, and it's acidic. And so you have basically acid rain, which we know contains like essentially only H pluses. You see little H pluses in the sky? That's not good to have. That's a negatory. Little H pluses in the sky. Now, when those H pluses come down, because the rain is acidic, they're going to be displacing your cations on the soil, which is natural. Now, here's the deal. The way that this works out is that when H plus is released from the roots, that's what, if you will, regulates the metals that you see here going into the roots. Where are these H pluses coming from now? The sky, basically. Is that from the root? So that means that the root is not calling for, if you think about it in a way, it is not asking for these metal ions to come in. Therefore, they don't come in. And what happens to them? Yeah, basically go down the water table. They're leached, forever lost. Good stuff? Awesome. So that's kind of an exchange. Now, we just talked about the three major organs, and what would be next? The three major what would be next? Tissues. Did y'all hear that? What is the other there? That's Joseph. What are our tissue types? Yeah. Dermal, ground, vascular. Dermal tissue. When we think of dermal tissue, what are we supposed to think of? Yeah, very external. You think of the epidermis and the cuticle. What's the cuticle? The thing on my fingernail, right? The waxy part on the outside, which prevents what? What's that called? Not through a leaf, though. Desiccation. Transpiration, desiccation, all these Asians. What? There's also perioderm, which is a way of saying essentially bark, not as in dog or a dog on the outside. Then your vascular tissue, and actually I don't want to talk about this just yet. Let's go to ground tissue, which is going to be basically your metabolic cell tissue, metabolism, which would include one of two things: photosynthesis, and also what else? Did I misspell something? Bark. That's a bad K, isn't it? Hey, look. Not a bard. Okay. Vascular tissue is comprised of two different styles or two different types or pieces. What are they? There's the xylem and there's the phloem. What's the xylem do? Not just water. Minerals. Typically, which direction? Up the plant. What are the two things that are happening to get things up the plant? TY. That means thank you, pressure, and what else? Well, actually, you know what? We'll cohesion. I think we should throw in adhesion. Then we'll throw in transpiration. So this was sponsored by a lot of different things, right? What's the phloem doing? What? Sugar transport. Typically which direction? Where? All the way down though? Could be up. When would that happen? When would you be going off the plant? Do it? When they're dying? I wouldn't go that far. I don't know. When would you need to call forward sugars? Let's think about that. The sugars end up in the root. So when, at one point in time, would you want the sugars to come out from the root? When is there an endergonic process? When is there a reaction requiring, or an energy requiring process that's happening at a time where there's no energy in that leaf area? What? It's not necessarily. In the spring. What are you doing in the spring? New leaves? Where there used to not be leaves? That's an endergonic process. It has to be powered by the sugars that you stored up from last fall. Cool. How are you?
Hi, I'm sorry to hear that. We have 2 light boxes so we can tell us what to do.
I've got 1.
Yes,
Yes, ma'am. Absolutely.
I'm so sorry.
No, very good.
I've been in the tax room.
Did y'all feel okay?
I have no idea. This has been a crazy morning.
I really lost like my first half is like it's got a little on the bottom, trying to figure out that it's also on the that was awesome. Every day. No idea. You don't know what's on the set.
I don't even know what the last time I went to.
Yeah.
Wait, that was on the. Yeah,
I don't know.
I thought it was on that.
I think she said one of the
Yeah.
You're asking the wrong.
What do you label?
Welcome out here in
Real images, right?
on the vulnerable funds and then yeah.
So then what is the label on the actual line? That's what I forgot the last time.
Okay.
Yeah.
So here we go. Do y'all understand why the sugar would travel the reversal direction in this case?
Yeah.
This is okay to understand? Yeah, and not the sink. Which is why there's now. It's not like today it's downward and tomorrow it's upward. There's like a point in time where this direction changes. And actually changes based on just essentially need. So I think that's okay with like the different types of tissues. Let's see. Cell types. There was this rule of 3, right? Kind of. And then this became the rule of 3 plus 2, which is 5. So it almost works out. There's sclerenchyma, parenchyma, and then there's what else? Parenchyma, which is the 95% chance of success question. Definitely that one. It's because these two have the same like features, if you will, and that's going to be basically for structure and support. And the unique feature that you have to remember about these two, the sclerenchyma and parenchyma, is that they have unique cell walls. And when I say like unique cell walls, I mean cell walls of varying thickness. What about parenchyma? What? Right. Think of the P, and it's all photosynthesis. And respiration. Joseph wants to call it the money maker. Is that how you write that down, Joseph?
I wrote it in my head.
Got it. I think collectively from this, I'm just thinking of metabolism is a general principle between those 3. Cool. Now, I can already tell just by the fact of like what I have with time that there's no way I'm going to get done with like all of the material. Let me jump through and talk about also maybe the cells of vascular tissue, that plus 2 parts. You have to know, let's see, we do need to know about like the tracheus and the vessel elements. So let's talk about your xylem cells, which are made of 2 things, the tracheids and the vessel elements. Some facts about those 2 is that they're both dead at maturity. Functional maturity. Now, what's the value in that, though? I mean, like, this seems like, well, what's the use of it dead? But actually, my question would be, there's a specific reason they have to be. What's that? Why would you have to have why are these vital cells that make plants vascular? I mean, that's like saying that the veins are not alive, essentially. My question is, what would be the advantage to having these cells dead? That's it. They're nothing but a shell, basically. Once they're dead at functional maturity, they're hollow inside and completely empty. They're essentially a shell, which is going to allow the water to transport down, correct? The foam, what's the value in it? Remember, it's what's carrying the sugars, correct? You have your seed tubes. And remember, these were alive, but they need a helper cell next to them. These guys are alive at maturity, but basically they contain only cytoplasm and nothing else. Right? Also from your seed tubes you have the companion cells. And what are the companion cells doing? They're facilitating the needs of your seed tubes, right? They facilitate the needs of the seed tube. So, I'm drawing this, my pictures are really bad, but you know what? I still draw them, which I think, A for effort. But this right here is a seed tube. So I'm going to write ST, that stands for seed tube right there. And then, next to them, I'm going to draw this neighboring cell that's kind of attached. That looks like a poorly drawn kidney, but it's actually a companion cell, so a comp C. Now, in the seed tube element, there's nothing but like the aqueous medium. So I want you to visualize this white space as being literally cytoplasm. In the companion cell, there's a nucleus, little mitochondria, little baby M's there. You got your little ribosomes, you got the ER system going on, and you got the business basically over here. Now, the organelles are not going to travel over, and I would assume to say, and I don't know, because I think I dropped botany, to be honest with you, but I'm pretty certain that this port has got to be way too small to allow the organelles to transfer over. So what it's going to be is, by the way, the name of this port, do y'all know the name of the port? It's an opening between plant cells. It's called a plasmodesmata. It's an opening between 2 neighboring plant cells. Cool? It's just like a gap junction in animal cells, essentially. An opening between 2 neighboring cells. But this is going to be too small to allow like organelles through. But the little biomolecules that need to travel through, see these little dots, they're not cellular particles, they're biochemicals of some sort. They can travel the left-hand direction into the seed tube cell. So it's not that they're not sharing like cooking utensils. They're just the command yourself giving food to the C2 element. Cool? Awesome. So that kind of concludes like your part about the 3 tissues, the 3 organs, the 5, or 3 plus 2 types of cells. So I'm pretty good with that. I need to talk about growth systems in, I guess, 4th period and then ecology in another class, so I'll kind of get my day planned out. Definitely keep looking at the YouTube website. I'm still recording these videos.